Alright guys, this is probability equation questions, GCSE 1 to 9 specification. So this first question, there are some red counters and some blue counters in a bag. The ratio of red counters to blue counters is 3 to 1. Two counters are removed at random. The probability that both the counters taken are blue is 1 out of 20. Work out how many counters were in the bag before any counters were removed. Okay, so where it says the ratio of red counters to blue counters is 3 to 1. So for every 3 counters that are red, there's gonna be 1 that's blue. And then how many are there? We don't know. So you could do it again. You could be another 3 for every 1 blue. But how many are there like this? So there's like 1, you could have 2, but we don't know how many multiples. So we'll just call it n for now. So we want to do a probability tree. So we'll start here. So we'll say this is the probability that you're going to pick a red, and this is the probability you're going to pick a blue. So the probability you're going to pick a red says 3 out of the 4. But how many multiples? We don't know. So we call it n. So we say it's 3n. It's going to be 3n red over a possible 4n. And then for the blue, it's going to be 1. There's 1 blue. How many times? We don't know. Call it n. So it's going to be n over 4n. And then here, the second time, we pick again. So we'll call this red. Probability of picking blue, red, and blue. So if we've already picked a red, well, the probability of picking a red is 3n over 4n. But the probability of picking a red again, how many reds are left? Well, there were 3n before, so now, if we've already picked one, it's going to be 1 less. So it's 3n minus 1 over 4n minus 1, because there's 1 left in total. But if we pick a red, but then we pick a blue, the probability is still going to be n, because we haven't picked a blue yet. There's still n blues left. So we say there's n and over 4n minus 1. But in here, let's pretend we picked a blue and then we pick a red. So we picked a blue and then we pick a red. This is the first time we're going to pick a red, so there's still 3n reds in there out of 4n minus 1. Denominators are always the same at each stage of this tree. But then if we pick a blue and we pick another blue, there's going to be 1 less blue to pick from. So it's n minus 1 over, you got it, 4n minus 1. Now, it's asking what's the probability that both the counters taken are blue. So we're only concerned with this here. So it's going to be this probability times by this probability, and it's going to equal 1 over 20. So we can write that in. It's going to be n over 4n times n minus 1 over 4n minus 1. Because you've got n over n, you can just cancel those n's, and you've just got 1 over 4. And we can just times this by 4, because it's like saying 1 over 4, just times it by 4. And that's going to equal 1 over 20. So we can write that in. We'll have n minus 1 over this 4 times of 4n minus 1 equals 1 over 20. Expand this out, so we've got n minus 1 over 16n minus 4 times minus 1 is minus 4. And that equals 1 over 20. Now, these fractions, I don't like them. So, we can times everything by 20 to get rid of it here, and times this by 20 here. And we can times everything by this here, so we can get rid of it on this side, and we'll times it on this side. So, that gives us 20 times n minus 1 equals 16n minus 4. Expand out, so we'll have 20n minus 20 equals 16n minus 4. Now we can add 20 to both sides, and so we can add 20 to both sides and take 16n from both sides. So if we take 16n from both sides, cancels there, and we're left with 4n this side. If we add 20 to both sides, get rid of it there, and we end up with 16 this side. Now all we've got to do is just divide both sides by 4, and we have n equals 4. Because we know how much n is, we know n is 4, so it's going to be 4 lots of this ratio of 4, which means there's 16. So the total number of counters is going to be 16. Okay, awesome. Right, that's it for that question. I'll see you on the next question.